One of the key skills that you will need to acquire when learning programming is the ability to identify, understand, and fix errors. In this video, we will look at the different types of errors you will come across when writing Python code. We have already seen that a Python program consists of one or more statements. A Python program is considered to be valid if all the statements in it are valid. And we can define statements validity in terms of two things: syntax and semantics. We can understand these concepts in terms of analogy to human languages. When it comes to natural human languages, we usually consider sentences as the building blocks of paragraphs. And you can break the validity of a sentence down into two things: syntax and semantics. Syntax refers to the rules of grammar that should be followed when constructing sentences, whereas semantics refers to the meaning of those sentences. Consider, for example, the sentence, "ate the cat the cheese." You can clearly see that this sentence is grammatically incorrect. The reason is that there is a syntax rule in English which says that a sentence should be composed of three things: a subject, a predicate, and an object. And usually a subject comes before the predicate and the predicate comes before the object. However, in this case, the predicate, which is the verb ate, comes before the subject, which is the cat. And because the subject and the verb are out of order in this case, the syntax of this sentence is incorrect. And we say that this sentence is syntactically invalid. What about the following sentence? The cheese ate the cat. So the subject in this case is the cheese, the predicate is the verb ate, and the object is the cat. And in this case, the subject comes before the predicate and the predicate comes before the object. Both the subject and the object in this case are nouns. So the syntax of this sentence is clearly okay. What about the meaning? Does the sentence make sense? Is it possible for the cheese to eat a cat? Or is it the other way around? So in this case, this sentence or the semantics of this sentence doesn't make a lot of sense. And we say that this sentence is semantically invalid. Although the syntax of the sentence is fine, it is still considered an invalid sentence because it doesn't make a lot of sense. So semantically, it is invalid. We can extend these notions of syntax and semantics to programming languages. So in Python, syntax usually refers to the rules that should be followed when writing statements, whereas semantics refers to whether a statement makes sense to the Python interpreter. And we have already seen at least one syntax rule in Python, and that is the rule for writing a function call. So here is this. So this is basically the syntax rule. So this is the syntax rule for a function call. So this rule says that in order to write a function call, you need to supply, or you need to write the function name first, and between open and closing parentheses, you need to supply what we call the argument list. So this is the argument list. And in the argument list, you will have a number of arguments, and these arguments are separated by commas. And you can have any number of arguments depending on the function. So some functions take one argument, some functions take no arguments, and some functions take n number of arguments. So you can supply them as many arguments as you can. And we have seen one example of a function call statement, and that is the print statement, or the print function call. So the function name in this statement is print, and then we have the open and close parenthesis, and then we have only one single argument, which is basically the string hello world. Keep in mind that this comma here is not the separator, so this comma here and that comma here, they are not the same. This comma here is basically to separate between argument, whereas this comma in here is basically part of the string. So as you can see, this function call satisfies this rule. So you have the function name, you have the open and closing parentheses, and you have the argument, or you have a single argument in this case. So the syntax of this statement is okay. So this is considered to be a syntactically and also semantically valid statement. Being a syntactically correct statement in Python doesn't mean that it is semantically also correct. And let's look at two examples of the variable assignments statement. So this is the syntax for a variable assignment. And we'll talk more about variables and variable assignments in more details in the next lecture. So what does the statement says? This variable, or what does this rule says? The rule says that a variable assignment is written in this way. You write the variable name first, followed by the assignment operator, followed by some value. So that's, you should supply one value, followed by an operator, followed by another value. And a value could be a number, for example 1, or it could be a string, for example hello. And an operator, so these are values. Operators, you have operators such as the plus operator, the minus operator, the divide operator, and for example you have also the multiply, the power operator. So this is, for example, so this is for the power. And here is one statement. So 8 equals 2, and this is power. So this is basically saying take 2 and calculate the value of 2 raised to the power of 3. So 8 is the variable in this case. This is the assignment operator. This is the first value, so we'll call this v1. This is the second value, and that's v2. And this is the operator in the middle. Now this statement, in terms of syntax, it is correct because it matches this rule in here. And in terms of semantics, it's also correct because Python is able to calculate 2 raised to the power of 3 and then takes the result and puts it inside this variable. What about the next statement? Again, if you look at the syntax, you have a variable name, you have the assignment operator, you have the first value here, which is a string, so that's the first value. The second value is the number 15, and then you also have the plus operator. So in terms of syntax, it is fine. What about semantics? We will see later on in the course that you cannot take a number and add it to a string. So this is a statement that the Python interpreter will not be able to deal with it. So this statement doesn't make a lot of sense to the Python interpreter. That's why the semantics of this statement is incorrect. So the key takeaway from here is that because you write a statement that is syntactically correct doesn't mean it is also semantically correct. And as we'll see next, you will often encounter errors when you are writing Python statements, and these errors can be of either syntax and semantics errors. In your programming journey, it's very rare that you'll be able to run the program at the first time without encountering errors first. And you should develop a skill of looking at these errors and trying to understand them and fixing these errors before proceeding for the next stages of your development process. So in general, there are two types of errors that you will encounter, and these errors are called syntax errors and semantic errors. Semantic errors can also be divided into two subtypes, which are called runtime and logic errors, and we will see the distinction between runtime and logic errors in the next slide. Before looking at the errors, recall the following diagram when we discussed the programming environments. Now, when you supply the .py file and you invoke the interpreter using the Python command, what happens is that the compiler first tries to see whether your statements matches the syntax rules or not. And if you have a statement that doesn't match a syntax rule, if you have a statement that doesn't satisfy a syntax rule, the compiler will be unhappy and you will get a syntax error. And here is an example of that. Consider you're trying to use this, or you have written this statement in order to print the hello world string to the user. Now remember, the syntax rule for making a function call is as follows. So you write the function name first, and then you write the argument list, and then closing parentheses. So you have open and closing parentheses. So if you look at this statement, you have a name, which is a perfectly valid name, and then you have an open parentheses, which is over here, and you have an argument, which is in this case is a string, and as we said, a function call can take any number of arguments. And then in the statement that you have written, or in this example of a statement, you have this closing bracket instead of a parenthesis. And this is basically where you have a mismatch between the rule, so remember this is the rule, and the statement. And because we have this kind of mismatch, what you will get from the compiler is what we call a syntax error. So the Python compiler in this case will complain with a syntax error, and you will not be able to see any result unless you go and fix this error. And fixing this error is really simple, it is really easy. All what you have to do is delete this bracket here and replace it with a parenthesis, and if you replace it with a parenthesis, in this case you can proceed. When you write a syntactically correct statement but semantically invalid, you will get a runtime or a logic error. Here is an example of such a statement. So here is again a statement for a function call that is syntactically valid statement. So the syntax of this statement is perfectly fine. So here is a function call. So here is the function name, and this is a perfectly valid name for a function. And you have an open parenthesis and a closing parenthesis, and you have your argument in here. So this is syntactically, it's okay, it's valid. What about in terms of semantics? Can the Python interpreter do something about this function call? In this case, no. And the reason is because the Python interpreter doesn't know what to do with this function name, which is called prnt, or print without the I. So the Python interpreter basically is clueless about this function name. And because of this, you will get a runtime error. So this is an example of a runtime error, and in this case this is an example of a name error. When it comes to semantics errors in Python, there are two types of semantic errors. There are runtime errors and there are logic errors. The difference between them is that a runtime error will cause your program to terminate, whereas a logic error, it may not necessarily cause the program to terminate, but it will cause wrong results in the output. Let's see some specific examples of these errors. So here's an example of a math expression in Python. Again, we will talk about math expressions in the next lectures, but in this expression, or in this mathematical statements, what we are trying to do, we are trying to divide division operators. So for example, if I want to divide a divided by b, in Python we say a slash b. So that's in math and that's in Python. So what does this statement do? What does it trying to do? So what we are trying to do, we are trying to take some quantity, we call it sum, and we are trying to divide it by count and multiply by 0. Now, you know, in mathematics this is basically sum divided by 0. If you try to do this in math, or even in Python, if you try to do this in your calculator, take any number and try to divide it by 0, what do you get? You will get an error. The same thing you will have in Python. So if you try to run this statement in Python, what you will get what we call a 0 division error. And this is an example of a runtime error in Python. So this is a semantic error because syntactically it is fine. It is a perfect, the syntax is perfect. The syntax is okay. So you have all the variable names, all the operators, everything. The rule for writing this statement is fine. However, because the Python interpreter doesn't know how to take a number and divide it by 0, you will get a 0 division error. So a runtime error will cause your program to terminate. So your program will stop and you will see an angry message from the Python interpreter. These are easy to fix. If you see this error, all what you have to do, you just come down to the statement and you fix it. The ones that are harder to fix are logic errors, because sometimes you will have logic errors and you will not be able to detect them until you see or you look at the results. And here is one example. Let's say that you want to calculate the average of 3 numbers, and the way to calculate the average of 3 numbers is you add the 3 numbers together and then you divide them by, let's say, by 3. And let's say you write this in Python this way. We will see later on that if you try to do this in Python, you will not get the correct average. So this statement is not correct. However, Python will not give you any runtime error. So you will be able to run the program. You will be able to see some kind of result, but that result will be incorrect. So we call this kind of errors where the program runs, so both syntax and semantics, well, to some degree. So there is, the Python interpreter is able to deal with this statement. However, the semantics is not what the programmer intended. This is what the programmer wanted to calculate, but the semantics for the Python interpreter is different from the semantics that the programmer has intended. And this is a classic example of logic errors. Now, the only way to deal with logic errors, or the only way to discover logic errors in your program, is to do what we call testing. So you have to spend a lot of time testing your code in order to verify whether they produce the correct results or not. And we'll talk about testing in more details sometime around week 3 or week 4 of this course. It's important in programming to spend a lot of time making sure that your programs are free from semantics errors, especially logic errors, because sometimes forgetting about errors or leaving code with some logic errors in it can cost you a lot of money. Take, for example, the explosion of the Ariane 5 rocket. On June 4th, 1996, an unmanned Ariane 5 rocket that was launched by the European Space Agency exploded just 40 seconds after liftoff. The destroyed rocket and all the cargo that was inside it was valued at around 500 million US dollars, which is equivalent to the amount of 320 million reals. The reason for explosion, it turned out that it was because of a software error. Specifically, it was what we call a number conversion problem. So a 64-bit floating point number was being stored inside a 16-bit signed integer. And because the number that we are trying to store was too large to be saved in the space that was supposed to be stored, the conversion from two different data types failed, and because of that, the rocket has exploded. Now, the code has been written in C++, and in C++ at that time, you might have made those kind of mistakes if you were not very careful. Hopefully, in Python, you will make fewer of such mistakes. One key thing that you should remember is just because your program runs, it doesn't mean that it is correct. You need to always make sure that you test your program and test it thoroughly to make sure it is free from errors, especially logic errors and runtime errors as well. On a last note, we usually call errors in programming and in computing bugs. So usually the term bugs, when we say bugs, we usually talk about errors, specifically logic errors or runtime errors. And there is a funny story for why errors are actually called bugs. And at the time when computers were the size of a room and they had a lot of mechanical parts, at one place there was this kind of a bug that was discovered inside the machine, and at that time, and this bug was causing the machine to produce some kind of wrong results. And because of that, the term or the term bugs has been used to describe errors that are found in software. So you can read this story here. It's an interesting story in this link, and it's a good historical note about software errors.